This video will cover investigating inverses, so this is something we did in class today. What you have to do is plot the points first and try to use one color for table 1 and a different color for table 2. So after plotting the points, we came up with a figure that looks like that. So what does it look like? Almost like a bird. Okay, I've never got that.
You can reflect it across both axes.
I'm sorry, say that again?
Reflect it across both axes.
Well, that's a very, very good assumption. In fact, it's reflected, yes, across y equals x. Now, what do you guys notice? To me, it kind of looks like a bug, like a spider or something like that. But yeah, maybe it could look like a fly, a bat maybe. So David already told us they are reflected. Very good. And what we're going to say is that they are reflected across the line y equals x, which is also the answer for the last question. A line of symmetry runs between those two graphs. Trace it with a dotted line or dashed line like I did. If you feel like you need a ruler, you may grab one. And the equation I'm already telling you. The equation for that is y equals x, which is the parent function of linear functions and also we know it has a very special name. What's the name of this graph, Andrea? Y equals x. Identity function. Identity function. And we call it that because the input, which is the x, is the same as the output, which is the y. But you guys got a little ahead of me. Let's see if we can answer question number 1. So what patterns do you observe from the table?
Table 1 x equals table 2 y and vice versa.
Okay, very nice. So all the values that we have here for x are the y values, right, in table 2, and vice versa. So I like that. So what we're going to say here is that, well, you can write whatever you want in your own words, but I would also like to add the following. The x and y values are interchanged. And I want you to get used to using that word. Today we're going to learn how to find the inverse of a relation or a function graphically by plotting the points by just switching x and y. So that's what we're going to be doing, interchanging x and y. On Friday, we're going to do the same thing, but algebraically. Okay, so there are different ways to do it. So I guess today we'll cover graphically and numerically by switching those numbers. All right? Yes. I'm sorry?
I'm not able to copy your question board.
So number 4, we just trace the line of symmetry, and that will be the identity function, y equals x. And instead of saying that it reflects across both axes, they reflect across that line. Because if we were doing a reflection across the x and y axis, it will look a little bit different. Let me find some room to do that. For example, if I take this point here, -5, 3, and if I want to reflect that across the x-axis, and I'm talking about this point, okay? If I reflect it across the x-axis, it's going to make the y value negative. right? So then the point will be -5, comma, -3. And then if we continue and we reflect that across the y-axis, then that will make the x value switch to the opposite sign. So in this case, the point will end up being here. You see? So then it will be +5, comma, -3. So even though it was a very good assumption, it's still not true because then it will not give us what we obtained with the segments connected in red. Okay? So I know you were thinking like, oh, they did two types of reflections, but instead of that, we just did the reflection across this line, the y = x. And so that one is probably the easiest of all because you just literally just interchange x and y, and that's it. Okay? All right, so we're done with this exercise. The one that says intriguing inverses, the handout. And so what I want you guys to do is to start plotting the points. Okay, so the points that I would like for you to use are the following. What happens when x is -6? So you need to find the y value. Also, what happens when x is -5? Also, when x is equal to -3, when x is equal to -1, and also when x is equal to 0. So I want you to find the y values for those particular x values. And what I want you to do for the next table, if you read the instructions here, it says use these points to name 5 ordered pairs that will be on the inverse relation of the function. So to do that, what you're going to do is interchange the x and y values. From the first table. David, what do you get? Tell me all the y values.
5.
Okay. Let's start with David, that's his, and then you. So 5.
0. 4. 0. 5.
Okay. And then the other David, tell me what you got on the next table.
5, -6.
5, -6. Next.
0, -1.
Okay.
4, -3.
Okay.
0, -1. And 5, 0.
5, 0. Okay, so I want to talk a little bit about some of these numbers, okay? Especially points like -5, 0 and point -1, 0. Now, you guys see that those points are located on the x-axis. And we also see that the y coordinate is equal to 0, right? So, do you guys know, how do we call those points? Have you ever heard that term? Zeros of the function, that's very good. Zeros of the function. There are other names that we give to those points. Anyone else? What were you going to say, Christopher?
The roots.
The roots? Awesome. And the reason we call them zeros is because the y coordinate is a 0. Now there's one more. If they're intercepting the x-axis, we call them the x-intercepts. Yes. Now you notice, would you guys say that this the graph of this relation is a function? Yes, yes it is. If we do the vertical line test, you will see that it will pass it at any point. So functions could have one x-intercept, 2, 3, 4, any number of x-intercepts, or they could not have an x-intercept. That's also okay. But if we look at the y-intercept, oh, and I already gave you the answer. The point that is on the y-axis, that one is called the y-intercept. Now I'm going to tell you something. A function can only have one y-intercept. Why? Not you. Not you. Yes. Correct. So if this function had another y-intercept here, it wouldn't pass the vertical line test, therefore it wouldn't be a function, right? Now let's see what happens. Oh, and there's one thing that I forgot to write down on the previous paper. I already closed it. How are they related? You still have your paper out, right? So question number 1, let's write down they are inverses of each other. Yes, the ones that you guys did on your notebook paper, they are inverses of each other.
What was the name for that?
Investigating inverses. So they are inverses of each other. All right, now that we have established, and that's why we have that name here, inverse. So this is a function, first table, and the second one we're just calling it inverse. So if you guys already plot your points, just go wait for me. And if you don't have your points plotted correctly, go ahead and correct your paper. Okay, so would you guys say that the inverse is a function?
No.
No. Okay, so Daphne, why would you say it's not a function? Very good. It wouldn't pass the vertical line test, so that's a good answer. Well, let's say no. It does not pass the vertical line test. And we know that because, well, that's a visual way to check. But if you also look at the table of values, we have here number 5 being related to -6 and also to 0. So we can't have that on a function, right? In other words, the x is repeating or the x is related to 2 different y values. Also, 0, when x equals 0, we have 0 is related to 2 different y values. All right. Now, what else? What else? Also, you see it has 2 y-intercepts. That's what Catherine was talking about, right? That's another way to see that it will not pass the vertical line test. Okay, so what I want you guys to do right now is to get a calculator, but let's do that in order. Okay, so with your calculator, you're going to go to the graphing section and graph the parent function of rational functions, also known as the reciprocal function. So I don't have my calculator software on my laptop yet, so I'm going to have to use the Elmo for this. But you could probably just hear what we're saying, or what I'm saying. Okay, so I want all of you guys to go to the home screen. And Chris, could you close the blinds, please? And we're going to go to the graphing section. And so I already have the function there. If you don't have that function, actually all of us, let's do the following. How can we make the table disappear? Okay, so Control T. All right, so I want you to delete that function. You could just hold the delete button. And then how do we enter a function? Press tab. So now I want you to enter 1 divided by x. And press enter. Now how do we make the table appear? Control T. Thank you, Julian. The blue button is control, and then T is one of the letters at the bottom. Okay, now if you look at your paper, we have x values that are decimals, right? We have an x value such as -0.5. You need help? Julian, could you help Leslie? So if you guys notice, what are the x values? Angel, read the x values for me, please.
1, 0.5.
Well, look at the ones on your paper.
-2, -1, -0.5, -0.4, 0.4, 0.5, 1, and 2.
Very good. So not all of those numbers are integers, right? And if we look at the x values given on our table, by default, they are integers. Yes? Do you guys see that? So we have that if x is -2, the y value is -0.5. We also have if x is -1, the y value is -1. And you guys see this thing here? When x is 0, the y value or the function value is undefined. It is not 0. It's undefined. Okay, so I'm going to show you how to get those decimals. So we're going to change the table settings. So I want you to press menu and then select table. And we're going to go to edit table settings. And what we're going to do here is go to table step, which is the second row. You could press tab to move to the second row. And I want you to type 0.1. So what I did was menu, table, and then edit table settings. And under table step, we press 0.1. Okay, so I'm going to press enter. And you guys see now we have more x values to choose from. So let's find the one that we needed, -0.5. -0.5 is right there. So if x is -0.5, the y value is -2. Okay, so Marina, I want you to tell me what will be the y value when x is -0.4. Okay, you need to get the graph. It is not confusing. If you get lost or behind, you need to raise your hand. No, we're gonna wait. If you guys have your table, go ahead and complete your paper. Okay, so Leslie, what do you get for the y values of the first table? Negative what? Okay. -2.5. Okay. Okay. I'm sorry, I can't hear you. 0.5. Okay, and after switching those values, really? After switching those values, we will get -0.5, comma, -2, -1, -1, -2, -0.5. I'm just interchanging x and y. We have, okay, help me out, Samantha. What will be the next one?
-2.5.
Okay. Matthew, what's the next one?
Um, 2.5 and 0.4.
Okay, Gustavo, what's the next one? I can't hear you. We already got that one? Okay. Angel? Daphne? Yes,
I'm not that no.
you're Daphne.
You're
Valeria?
Yeah. 0.5 and 2.
0.5 and 2. Okay. So now, do you guys graph them? Mm-hmm.
Yeah.
Okay. So I guess I will be collecting your work today. So if you graph them, Leslie, what do you get? The same graph, right? If you graph them correctly, so if I graph this point, -0.5, comma, -2, it will be somewhere here. The next one, -1, -1, is here. -2, -0.5 is here. -2.5, comma, -0.4 is there. Now, +2.5, comma, 0.4 is here. 2, comma, 0.5 is here. 1, 1 is here. I think all of you know how to graph that. And then we have 0.5, comma, 2, and that is here. And so, of course, if we connect them, we will obtain the exact same graph. So what that means, and I'm going to give you the notation for an inverse function. So if our original function was f of x is equal to 1 over x, remember f of x has the same meaning as y. For the inverse function, we will have f inverse of x, it is 1 over x. That doesn't happen too often. This is a very rare thing. Sometimes we will obtain the same function, but not always. So we're going to stop with this handout here. Next time when we come to class, I want you guys to work on this. I'm going to check to see if the internet is back on so I can explain the problem. But just to give you a little heads up of what you will be doing, and I do not want you to just be waiting on me to write down the answers. I cannot stand that. I do not appreciate lazy people. Is that clear? So when you come here, you will do the following. You will select some points from the graph, any x values that you wish. For example, -3, -1, 0, 2, and 5. This is the parent function of linear functions, so the equation is that one. Don't be packing your stuff. I didn't say you could pack your stuff. So you will find the y values. So for this will be -3, comma, -3, -1, comma, -1, 0, 0, 2, 2, 5, 5. If you don't know what the equation is, then you need to look at the graph and see if you can find those points. The next one is quadratic, so I would suggest you use numbers like -2, -1, 1, and 2. So you will determine the y values. And for the next table, you will do the same thing that we were doing. Interchange the x and y because we're finding the inverse. In fact, just start working on that. And I will just go over the project next time.
give students at home or when we start? March 4th.
No, you guys have already a lot of homework. I'm giving you 2 homework assignments. I'm also giving you a project, so I'm okay if we just finish this in class. Okay, so continue to work on that. We have 3 minutes until class is over, so yes, I am going to keep you for 3 more minutes.